Hey guys, it's Alex D from 1698V.
It's Richard from 1698B.
And this is Grant.
So this is our world's bot explanation. Starting off with the drivetrain, we're running 66 watt, 450 RPM on 3.25-inch wheels, and you can actually see that we use plastic shaft collars on our drive base, and it's very lightweight compared to steel shaft collars, but we got these really close to worlds, so you can see some of them are actually still steel because these are really big and wouldn't fit. But next season we're definitely going to be using this a lot more. And also you can see here we're using all aluminum nuts. So this is an M4 screw. So not only is it lighter, but it's also smaller and thinner, which just continues making it smaller. And over here we use the McMaster spacers to make sure that the wheels didn't hit it. And a lot of teams use stack motors, but we just didn't want the extra weight, and we couldn't really fit anything up there, so we just had to put all three motors on the bottom. And then next up, our tracking wheels. Like we use a lot of other teams use poly, but we just found metal to be a lot easier to use, and it was also the perfect width for these double stacked 2-inch wheels. And yeah, we have one horizontal, one vertical, and these work pretty well.
Except in World's Finals.
Yeah, except in World's Finals 3. When one of the rotation sensors, I think it was the horizontal one, it disconnected, and that's why our autom didn't work. And then over here, our first stage intake. So basically, we just have four flex wheels here on a high strength axle. Originally we always use double chain, but for Worlds Bot we just use single chain for more weight reductions. And then triangle brace here just to add more rigidity. And then down here, we use laser cut sleds. That it just allows the ring to go up really smoothly.
On the second stage here, we have these hooks. We have three of them. And this was kind of a design that just kind of stayed constant for Mall of America. These sprockets over here used to be smaller. We made them bigger because centripetal force or whatever. I failed physics 1, but it's fine. So, yeah, pretty consistent intake. And one thing about the chain was that we actually at US Open,
It broke.
at US Open, we lost semifinals because the chain broke. And we were gonna do stuff to fix it, but this chain just never broke on us and was fine. These hooks were laser cut. We bought a $2,000 laser cutter, and now we can't use it because
R25.
Thank you, RDC.
Yeah, and also one thing that we found with the hooks was that the chain, it had to be running in the different direction than the hooks. And in US Open we had the wrong direction, and that's kind of why it broke. And we also were really careful about hitting this ladder because it just weakened the chain a lot.
And so our Lady Brown, it's a pretty standard Lady Brown mechanism, but there's some special sauce in here. So first off, two 5.5 watt motors. That was nice. And then again, some laser cut parts here, and this allowed us to sort of customize like this connection. And yeah, it's pretty lightweight. Also, this part's kind of sketch. So we have a bumper sensor over here to sort of control like the position of the Lady Brown. But the thing is, it's like when this came down, we realized that this side was like kind of uneven. So if you look right here, we just stuck something here, put a rubber piece here, and that worked pretty well. We also have the, as Alex calls it, the patented Diddy mechanism, which is just a trap door that allows. So if I put a ring here, then it's a lot more secure versus if there was no trap door here. A lot of teams ran friction fit. We also have friction fit, as you can see here, but this was just adding a bit of security. And on our old robots, we had a piston control this with a distance sensor, but that was pretty heavy and kind of complicated. So we realized that using like a string pulley system would just be better. Also, the Lady Brown kind of triggers the hang. So when I put it down, you can see these two standoffs, I guess, crush the hang. And then when we lift the Lady Brown up, these hangs kind of pull up because of the rubber bands. Cut with scissors. That was pretty cool. And it honestly didn't take us too much time to figure out how to customize it. We kind of just stuck it on and it worked first time. So, and then another thing to help with the hang was these little gears on the bottom. So like when we hung without these, sometimes like if we went in too fast, these C channels would like stick in the bottom, and that wasn't good. We just get stuck. But with these wheels, that really prevents that. Also, probably the most sketch part of our robot. You can see here that as a hard stop for the hang, we have these laser cut. Brown up. We have these laser cut holes, and then what we did was we actually, if you look closely, we took a bunch of zip ties, tied them around, and yeah, that kind of made it as hard stop. It's really sketch, but it works. Wouldn't recommend you do this though because it looks weird. I mean, it worked for us, so can't really complain.
Yeah, and also build quality tip. We use a lot of standoffs for a hang. As you can see, standoff here, as well as the standoff here. And one thing you might notice is that they're all using standoff retainers. And the we actually didn't have these at the start of the season, so we didn't use them as much. But none of these standoffs are bending, which in a hang, standoffs are very prone to bend. So these standoff retainers helped a lot, especially when we're using aluminum screws, which are really weak. We didn't want to use steel screws, so these standoff retainers helped with the bending a lot. Okay, next up is the Mogul clamp. We ran a different Mogul clamp than a lot of other teams. A lot of other teams, they had just had their pistons angled from this triangle brace on the intake, and they were just directly pushed down. But what we found is that it's really easy to get ripped out by like a tipper or like a goal rush clamp or maybe just another clamp. So instead, what we have is our pistons are exactly mounted at 90 degrees. And when they're pushing down, instead of pushing outwards, the pistons are actually pushing inwards. And so this kind of creates a locking effect. So it's really hard to like take it out. And also, because we're only using 2 screws and nothing else to push it down, we can clamp and still score at almost like any direction.
Yeah, and also these little polycarb guider pieces were kind of nice. Like if the goal was say here, our driver could just like drive into it and it would still clamp pretty well. It's a bit off, but like the rings would still fall on.
Yeah.
So
So this is like showing how the clamp can score at all directions. So I'm gonna see perfect scoring on that direction, and if I rotate it a bit, we can clamp it again. And the screws kind of rotate the goal, but like yeah, again, like it can just score kind of perfectly in any position. Like even if I push it in slanted, like at a very weird angle, it's still gonna be able to score very well. So this is like really good for our autons because our goal might not be perfectly centered, but it'll always perfectly score because also partially because our the standoff over here, which we added to stop the goal, and of course standoff retainers everywhere. And at a scrimmage, shout out to Saratoga High for hosting it. We actually found out that these 2 wedges, which are supposed to make the goal tilted, when it was clamped over here, uh the top of the goal would actually be pushed down. So we had to add this beam over here, which would kind of like push it upwards, and you can see there.
also, a lot of you may look at this L channel, and this channel looks kind of beat up, but there is a high strength axle underneath. So even though it looks really beat up, it's still pretty stable.
Yeah, and the only reason why we had this L channel was because we were too lazy to drill holes in the high strength axle for this, but like, it doesn't
work.
really make a difference.
But it's fine. We made
Yeah.
dough. It doesn't matter. So
Yeah, and then now I'm gonna talk about the tongue mech. So the tongue mech is basically a lot of teams have it. It's really scuffed, as you can see. Like it has this. It's really scuffed. It has a bunch of metal bars over here, and this allows us to like rotate it to as much as we want. And like every single time, we would be able to rotate it to the perfect position to get the 3rd ring. And one thing that's even worse about it is that if we activated the tipper, and it would actually push it in. So this is just a one-time use tongue, and then before each match, we would have to bring it out.
Richard, talk about the goal rush.
Yeah, sure. So what we do for goal rush is we use this arm here and we clamp down on a goal. And why our arm is really good and better than other teams is that So like basically we have this thing called auto clamp, which basically uses a distance sensor and the code to sense when the goal is nearby, so it automatically clamps onto the goal when the distance sensor detects it. Like I will show you an example right now. Wait, do you know the button for it?
No, it's just auto clip for a reason.
Yeah, see.
And so
like it automatically clamps onto it.
And you may notice that there was like barely any air, but it's fine because yeah. Also, I think one more thing we can demonstrate is like the controller actually vibrates as soon as it checks something. So shut the fuck up. So
See, Sean.
So I don't know if you can hear this. You might put it in. Just there's a little shake.
All right, so the auto clamp, it's really effective for Auton because we can like clamp the middle goal consistently. We actually haven't missed goal rush a single time at Worlds, and we didn't lose a single Auton at Worlds except for Finals 3, where our Auton didn't work. Like because like this didn't unclamp properly, but like other than that, I mean we use it for positive corner, like stealing the positive corner goals, because it's really effective when the driver can't see what's going on in the corner, but they can just reach their arm in and like automatically clamp onto the other team's positive corner goal if they want to try to drag it out or something like that.
Yeah, there were multiple clips you may have seen of our driver stealing people's goals and also getting DQ'd in semifinals 1 in Dome. But to be fair, we could not see that we clamped onto the other team's robot. So yeah. I think one more thing on our robot is this tipper mechanism. So it kind of just folds out like this. And what this thing was good for was two things. So first of all, if it was a goal with not that many rings, well, it is a tipper. So if we just drive in, then we can sort of hold the goal like this. And then this was originally made as like an alternate for the arm. Then we realized the arm was just better, so we didn't really need it. But Saratoga, but there was a scrimmage with NorCal where we found out that the tipper could do this. So if it just clamps and then we can just drive back with the goal. So as you can see, it hooks on, tip the goal like that. And that is really good for getting other goals out of the positive corner. And we actually won finals 3 in our division off of that.
Alright, so I'm the driver, and to untip goals, now you might see that I can do this, right? But sometimes this doesn't work. So, what you can do instead to make sure that it works every time is put the lady ground down, and that gives some more slots.
Yeah, and that's all for our robot explanation. So see you guys at Mall of America and Pushback.
Oh wait! I have something to say.
No!
This Richard from 169AB, like Richard Alliance is like the best alliance in the world. It's like yeah, like we're from Richard Alliance, and like they're just really good. Yeah.